in Module 11 in the book Problem-Solving Guide for Electromagnetism and Optics, Mirrors and Lenses. In the first lecture, we focused on lenses. Here we're going to do a couple of problems with mirrors. Here's a good one. An object is placed 25 centimeters from a converging mirror. Converges the light. Has a focal length of 50 centimeters. There's our converging mirror. There's a good diagram. We'll use a Snickers bar as the object. And we see the focal length is 50 centimeters. The Snickers bar is 25 centimeters away. So we have a good scale, a proper scale. Incoming light that comes in parallel will get reflected, not refracted, reflected through the focal point, like that. In parallel, out through the focal point. Go to the center of the lens is always a good idea. It gets reflected off the mirror as if it hit a vertical mirror. So the angle of incidence is equal to the angle of reflection. It's just reflecting off a mirror, and it's like a vertical mirror, just a normal bounce. These rays are not converging. The image is going to be virtual because the rays aren't converging. It's going to be behind the mirror. The observer is looking into the mirror, can see the light coming off the mirror. To find the image, we have to trace back the rays to where the light appears to be coming from. There's no light behind the mirror, but it's where the light appears to be coming from. So we go backwards from that ray, backwards from that ray. It appears to be coming from back here. This is the top of the image. Let's put it in. There's the image of the Snickers bar. It's certainly bigger than the object. And let's see what the equation tells us. 1 over f is 1 over p plus 1 over q. F is 50 centimeters. P is 25 centimeters. Those were both given. We have to solve for q. We subtract 1/25 of a centimeter, 1 over 25 centimeters from each side. Get a common denominator. 1 over 25 becomes 2 over 50. We do the math, and we get that q is 1 over q is 1 over minus 50. Q is minus 50, and that's all good news. Looks about right. First of all, q is negative. It's virtual. It's not a real image. And the focal length is 50, and it looks like that image is about 50 centimeters from the mirror. And the magnification looks to be about twice as big. This is 25 centimeters away. That's 50 centimeters away. The magnification is 2 because the image is twice as far away from the lens as the object. It's all nice and consistent. So the converging mirror produced a virtual image, and it can if you put the object inside the focal length. So converging mirrors indeed converge the light, but that doesn't guarantee a real image. Now let's do a diverging mirror. You're always going to get a virtual image with a diverging mirror. This is problem 2 from practice exam 4 in the textbook. When an object is placed 20 centimeters from a diverging mirror, it produces an image that's half the size of the object. What's the radius of curvature of the mirror? Draw a ray diagram. Is the image virtual or real? Well, problem C, part C is really trivial. It's diverging. It's a diverging mirror. The image has to be virtual. But we have to get A and B, so let's draw a good ray diagram. There's a diverging mirror. Spreads the light out. We'll use a sequoia tree as an image, as an object. Light that comes in parallel will reflect off the mirror as if it came from the focal point. Don't go down here. Think about you're throwing a baseball against this curved wall. It's not going to bounce down here. It's going to diverge as if it came from the focal point. There's the focal point. Appears like the rays coming from back here, but it's not. It's coming off the mirror. Now we're going to get the other ray, go to the center of the mirror. Reflects off. Angle of incidence is equal to the angle of reflection. These are diverging. That ray and that ray are not going to come together. They never come together. They appear to come together behind the mirror. So we extrapolate that backwards. There's no light back here, but we think there is. The observer is looking into the mirror. She can't see the rays going toward the mirror, and she can't see any light behind the mirror because there is no light behind the mirror. The image is where the light appears to be coming from, which is right there. And that's consistent with the problem statement, which is that the image is half the size of the object. And it looks like this is about 10 centimeters behind, as it should be, because the object is 20 centimeters from the mirror. And the image is 10 centimeters from the mirror. That's a magnification of 1/2. So now let's use the equation and see if we get similar results. The object distance is given as 20 centimeters. The magnification is 1/2, so we know that the image is 10 centimeters away. It's a diverging mirror, so we know the image is virtual, so we put the negative sign in. You have to be careful if you want to get the right answer. So get a common denominator. 1 over 10 becomes 2 over 20. We do the subtraction. We get a negative focal length, minus 20 centimeters. And we better get a negative focal length because it's a diverging mirror. If you get a positive focal length and it's a diverging mirror, you did something wrong. So it looks all consistent. We're very happy with that result. Now let's try to answer the question. Don't forget about the question. A, what's the radius of curvature of the mirror? Well, the focal length is 20. The radius of curvature is about twice that, 40 centimeters. The radius of curvature is back here somewhere. And if we draw a line from the radius to the mirror, it's going to split that right in half because the angle of incidence is equal to the angle of refraction for any ray coming off the mirror. There's our ray diagram. We already did that. And of course, we entered part C. It's a virtual image because it's a diverging mirror. Here's some tips for this chapter. A 6-inch ruler and a protractor is very nice if you want to be methodical and careful and get the right answer. Draw some good straight lines. Many times when you're practicing, it's very likely that you're going to get a ray diagram that's completely inconsistent with your thin lens equation. Your equation's telling you the image should be over here, and your ray diagram puts the image totally different place. And take that inconsistency seriously. You probably forgot a minus sign somewhere. Virtual images have negative image distances. Diverging mirror, diverging lens have negative focal lengths. That's the lectures for Module 11.